number of sessions you have attended before you are allowed to do the exam, you qualify. So I'll be taking the roll call every time we have a class. The beauty with the Microsoft team is that it always records those who are present in class. So ensure that as you log in, you type your official names on the gadget you are using, and probably type your name, and then you can put in brackets your registration number, because we will be taking those records, and they will be used to assess those who qualify to do the exam at the end of the semester. Remember, university policy is that you can only be allowed to do an exam if you have attended at least 2/3 of the lectures. So those who don't attend class, tell them that they may not be allowed, or they will not be allowed to sit for the exam if you have not been in class. So that's university policy, and will still affect it. So usually my style of teaching may be different from what you have been used to, because I give a lot of assignments and quizzes. And if I give an assignment, I ensure that you do it and submit on time. If you fail to do one assignment, that will water down all the other things that you have done, and it will give you an incomplete grade. Incomplete grade means that you haven't done all the coursework. Even if you come and do the exam and you score 70 out of 70, you still have an incomplete grade. So do assignments, submit on time. If a cut is given, do it, and then also submit on time. Same to the final exam. And because as someone has already highlighted that this class has two groups of students, one group from Kenya Science, the other group from Kikuyu campus, the lessons or the sessions will be exclusively online to take care of all the two groups. So you need a laptop or a very good smartphone that can enable you to attend classes online. Numerical method cannot be done without a calculator. So you need to have a calculator. And the recommended calculator for this course is Casio FX991 ES Plus. The calculators you used in high school, FX82MS, may not be useful for some computation that will be carrying out in this course. So ensure that you have the right form of calculator. As usual, you need an exercise book, pencils and rubbers, and all those writing materials. And for instance, being that we'll be doing online classes, then you need to have a powerful internet connection. So the main objective of this course is to familiarize ourselves with the mathematical computations and analytic computations, which have applications in science, economics, and engineering. And so being that we are going to do a lot of numerical computations, most of which you can't do them by your head or by normal calculations, you must have a calculator. A calculator is a must for this course. So anytime we have a session, ensure that you have a calculator. So so these are some of the expected learning outcomes. I will start by analyzing errors, and then discuss about finite differences and the relationships among the finite differences, and then solving problems using finite differences, Then you'll also discuss about interpolation. Then
Hello.
Numerical differentiation, numerical integration, and solve nonlinear equations.
Hello, sir. Hello, sir.
Yes.
Have you shared the screen or not? Because we are not. I'm not seeing the screen.
Is everyone not able to see the screen?
Yes, sir.
Yes.
Yes. Oh. Yes. Let me just check.
Now
It's
I'm
now.
seeing.
Is it popping up now?
Yeah. Yes, sir.
Yes, you
Thank
can
you.
see it.
Okay, good. Sorry for that. Sorry for that technical. I thought that you were able to see it. Thanks for reminding me. So
There's another issue right here.
this
We've got another issue.
which issue?
Now that the class is exclusively online, as you said, and we congratulate you for that.
Yes.
The university is no longer giving us the summer data.
The university is nowadays not giving the bundles.
Yeah, they're not giving us the summer data, so you can try to talk to them to give us that data, because buying data is very expensive.
Oh, I didn't. So when did they stop giving out those telecom lines?
From semester 1 this year and that year.
Okay. So I
But
lies
for me, I
with the
actually,
yes.
for me, I have.
What do you have?
Yeah, yeah.
So what criteria do they use for you to have and others to miss?
We don't understand
for
what
me,
going on, because most of the years in Kenya Science are no longer getting the summer data.
Or you see what usually what happened is that the university knows that all students apart from second years in Faculty of Arts are the ones who are doing online because they were not given rooms in school. That's why even you had Mondi saying that people are in school. So that's what they assume. So the only cohort that is assumed to be doing things online is the second years in Faculty of Arts. But then I'll liaise with Ms. Muruki to actually see, because actually she's the one who said that the course is a group of 2 different colleges, so it should be done online. But I'll liaise with her to know if they can get solution for that.
So you know.
Yes.
Yeah, but you know that even if everybody is in school, not everybody lives in school. Besides, nobody can make it to the Uhuru Hall to use the Wi-Fi there.
The assumption is that when people are in school, they should be taught physically. That's I'm saying that I have to tell her to provide a solution, because she's the one who said that this course is combining 2 colleges. So you can't combine 2 colleges and you bring them in class. It's almost impossible. Because now you'll start now raising concerns of how do we get fair if the class is at Kenya Science if I'm staying in Kikuyu, and vice versa.
Oh, you understand that, so you can talk to them.
Yeah, so the original idea is that if people are in school, then they are doing their classes physically. And if they're in school, the assumption is that when you're in school premises, then you have access to Wi-Fi, which is actually not true in general. But there's some sports in school where there's also no Wi-Fi. So I'll share with her and then try to see if she can provide a solution to that. So there are usually 2 cuts. Cut 1 is 10%, cut 2 is 10%. All the assignments will be converted to 10%. University of Nairobi still retains the total score for final exam to be 70%. So when we add all those, we get 100%. So University of Nairobi grading system is one of the fairest grading system around. That to get an A, you only require 70 and above. And then any marks between 60 and 69 is a B, 50 to 59 is a C, 40 to 49 is a D, 0 to 39 is an E. And now that I remember when I teach students from Kikuyu campus and Kenya Science, I'm usually very happy because I know that I'm not dealing with students, but I'm dealing with teachers. So I'm dealing with colleagues. So when you are dealing with colleagues and you are dealing with teachers who are going to be also creators of other very important people in the society, you are always assured that you are dealing with people who have sane minds and they think in the right way, that as because they are going to be teaching students and telling them to get S, then they should also be getting S. So if A is not your best, then you can get a B. To the worst, probably maybe say a C. But then as a teacher, you will not have moral authority to tell your students to score S if you are going to give us a D and an E. So that's a challenge to you as a teacher. For you to have that moral authority to go and tell your students that you expect them to get S, let it start with you. So that's usually a challenge to you as a teacher. So ensure that you do what you are going to tell your students to do. And I know no teacher can actually aim for his or her students to score anything less than a good grade like a B or an A. So let it start with you. Aim to score those S and you'll get them. Aim to score those Bs and you'll score them. But please, it will not be good for you to score an E and in May you are going to tell students to go and score an A. So that is just a personal challenge that you must always remember when you are in class, that as you tell others to perform well, let it start with you. So do your best. I'll try as much as possible to support you where I can to ensure that you get maximum out of this course. And not just this for course alone, but also in the other courses. Ensure that you do your best so that you don't fail in any other course. Because if you fail and you're going to teach people to pass, then that's a contradiction. These are some of the chapters we are going to fully discuss. I will start by error analysis, solving algebraic and transcendental equations, discussion about finite differences, interpolation, and then numerical integration and numerical differentiation. There's someone in the question?
Please try to scroll your screen, sir.
Try to scroll.
The screen is not scrolling.
What? Which slide are you able to see?
I'm seeing students are
The
required.
first slide there, Ghana.
Where?
Slide ya
The
kwanza ndio
slide
tunaona.
shows the type of test percentage cat 1, 10%, that one.
Or we're still seeing cat 1? Are you not able to see the slide with the chapters?
Yes,
I'm not even seeing the screen myself.
It's visible. Is it still blood from your end?
It's clear now.
Visible.
Good. So these are some of the references. I'll share some of these books, and you can as well also get them from internet. And any other textbook with the courses, the chapters given in the course outline can still help you as a reference. That teaching is not done physically. That's online, not physically. And then please attend all the classes. And I wish that all of us are going to enjoy the course and are going to do their best so that at the end of the semester, all of us proceed to the next level without having any trouble. So with those many remarks, I invite any question before then. Now we can write anything. This document has already been shared with you, so you can always have a look at it. Any question before can discuss anything?
Will we be getting the notes?
Notes, you write them when you are discussing. You cannot study math by watching. Any other? Any other question? Okay, maybe I did. Maybe my friend, I didn't understand your question. So when you say will we be getting notes, what did that mean? Did you mean handouts? Did you mean reference books, or did you mean what we are writing on the board?
When you ask for notes, we ask for the document you're using. You send us the notes, not generally what you write in a class, what we'll refer back to after the class.
There's no problem. There's no problem. That can always they can always be given. But remember, to be a good math student, but I was to tell you this from the start. To be a good math student, you have to be very stupid. To be very stupid in the sense that you follow instructions and do what you have been told to do. So if you are very stupid, you are going to go far. But if you are going to be very clever, you will not go far. Clever in the sense that if you are told to do an assignment, you don't do it. Clever in the sense that if you are told to copy notes, you don't copy them. Clever in the sense that if you are asked to come to class, I don't come to class on time, you'll be in trouble. But if you are a person who is going to follow the instructions, then you are going to have a very smooth sailing. But I know people from Kenya Science and Kikuyu campus are always very serious, unless you'll be the first ones to break the record. So error analysis is the first chapter. Okay, am I blocking anyone else to give you a question before we start? So what do you understand by the term an error from your Form 3 work? What is the meaning of the term error? What is the meaning of the term error?
Error is a small mistake.
What do you mean by the term error?
The difference between a true value and an estimate or an approximation.
Yeah, the difference between the true value or exact value and the approximate value is what we call an error. So we say by an error, we mean the difference between the true value. So true is also what we call exact value and the approximate value. So i.e. error is given by true or exact or actual value minus approximate value. So this is how we define error, the difference between the exact value and the approximate value. I hope you can see my screen and what I'm writing.
Yes.
Yes.
Good. Yeah. So error, we mean the difference between the true value and the exact and the approximate value. So there's what we call absolute error. So absolute error, you get the absolute value of this error, which is simply absolute of true value minus approximate value. And you know, when you what we call absolute mean that we are, if the number has a negative sign, then we are ignoring the negative. So only indexing the positive quantity of the number. And then relative error is given by error over the true value. And remember, the term true is the same as exact or is the same as actual. So we'll be using them interchangeably. Relative error is error over true value. And in most cases, when we'll be talking of error, we'll be implying the absolute error. Then there's what we call percentage error. How do we compute percentage error? From your Form 3 work. Percentage error is given by?
Percentage error is
Relative error times 100.
Correct. Relative error times 100%. Correct. So relative error times 100%. So note the main goal of this course is to carry out numerical computations and reduce the magnitude of error as therefore avoid premature rounding off and truncation so that almost all the computations we are going to carry out in this course will be approximations, and we try as much as possible to reduce the magnitude of error, and the reduction of the magnitude of error will be achieved by avoiding doing premature rounding off and unnecessary truncation of numbers. So for example, if you are doing a computation and you get on your calculator, you have a value like 9.763258972, then you use 9.763 in your computation for the next step. That is where the problem starts from. So free advice, as we begin from day 1 up to the last day, avoid what we call premature round off and truncation of digits when you are carrying out numerical computations. So propagation of errors. Error propagation. Let X and Y be exact quantities. So exact or true or actual quantities. And then denote by X and by Y to be approximate values of these quantities X and Y. So let by X be the approximate value of X and by Y be the approximate value of Y. Let epsilon sub X and epsilon sub Y be the error magnitudes of X and Y respectively. So we are taking the trend that exact quantities, we write the letters without a bars. Then approximate quantities, we put bars on the letters. And then we use epsilon sub X and epsilon sub Y to represent error magnitudes in the two quantities X and Y. So the first operation, addition. So X, okay, let me in form of a question. How do we relate X by X and epsilon X? Are we able to relate the quantities X by X and epsilon X? What formula connects these three quantities?
X minus
Unmute and then say the answer. The formula connecting X by X
minus
and epsilon X from the definition.
X minus X bar is equals to epsilon X.
Correct. So X minus by X is the same as epsilon X, because we say that if we take exact quantity minus approximate value, then this gives us the error. So that's why someone is able to give the correct formula that for these three quantities X by X and epsilon X, then this is the formula that connects them. So the exact minus the approximate gives us the error value. Then similarly, Y minus by Y should give us epsilon Y. That simply means that the exact quantity of Y minus the approximate quantity of Y gives us the error in Y. Then with that, from definition, we can say that X by X alone is the same as X minus error in X and bar y alone is the same as y minus error in y. Call this equation 1, call this equation 2. Then add equation 1 and equation 2. Adding two equations means that you put same side, you add the left-hand sides of the equations and also add the right-hand sides of the equation. So I'll have bar x plus bar y is equals to x minus error in x plus y minus error in y. I hope up to that point things are flowing.
Yes. Tuko pamoja.
Good. So then now, when we are adding, we can always put these two terms together, x and y together, and then error terms, we can put them together. So we have bar x plus bar y is x plus y minus error in x minus error in y. Then there is no mistake by saying I put bar x plus bar y in brackets. I still have the same sum equals to, I put brackets for x plus y. Then if I have to put the error terms in brackets and I put out a negative sign, so what should I write in the brackets?
Positive.
Addition.
We'll have addition, okay? So error in x plus error in y. Good. Then this is our equation. You can always play with it without breaking any rules of algebra. So I can as well say x plus y minus bar x plus bar y should give me what will this difference be?
Minus epsilon x plus epsilon y.
Will it still be minus?
No, it will be
Yes.
positive.
Will now be positive, okay? Yeah. So this will be error in x plus error in y. Then you see this first bracket is summing the exact quantities x and y, and this other sum is the sum of the approximate values of x and y. So whenever we have an exact minus an approximate, it always defines
an error.
An error, correct. So whenever you have an exact quantity subtracting an approximate quantity, then it must always be defining an error. So therefore, with this notation, this quantity on the left-hand side will be nothing but error in the sum. So this will be the same as error in x plus y is the same as error in x plus error in y. And this is what this is a formula that we really we wanted to derive. And it's not a very new formula. You have seen this formula before in your high school. So we are saying that the error in sum of two quantities is equal to the sum of the errors in the respective quantities. So if you are summing two numbers and you know the errors in the each of them, then if someone asks you to provide the error of the sum of those two quantities, it's as good as simply adding the errors in the two quantities. And the same can be extended to n different quantities. So if you have n different quantities, then the error in the sum of those n quantities is simply the summation of quantities in each of them. So let's go to the second operation we call subtraction or difference. So at this point, then I'm permitted to say, we know that. So we know that x minus by x is error in x. So which means that x bar is the same as x minus error in x. I call this equation 1. And y minus bar y is the same as error in y, which means bar y alone is the same as y minus error in y. So we call this one equation 2. I think that statement of we know that makes sense at this level from the first case.
Yes.
Yeah, good. So then now we want to see how the errors propagate when you are doing the difference or you're subtracting two quantities. So we do the same stuff we have done in the first case. So you say equation 1 minus equation 2 gives, similarly subtracting two equations means you subtract the two sides of the equation and equate them. So we'll have by x minus by y equals to x minus error in x minus y minus error in y. So remember, brackets must be included because this y minus error in y is now one quantity. So when I'm saying I'm subtracting equation 1 and minus equation 1 minus equation 2, I have to include this bracket so that I don't mess up with the signs in the equation. So this will give us by x minus by y is x minus error in x. Now I can open these brackets as minus y plus error in y. So when I write plus error in y now, it should make sense from the opening of brackets. Minus minus is plus. Then similarly, we put x's together and y and error terms together. So I say x minus y minus error in x plus error in y. So I'm just regrouping the terms on the right-hand side. So this will be by x minus by y, x minus y. If I have to force a bracket there, then what will be the sign of error in y?
A positive.
Negative.
Negative, correct.
Negative.
So I need to have a minus sign here. So that now, if I do this, there's no mistake I'm doing to the equation. So I can say, if I say x minus y minus by x minus by y is the same as error in x minus error in y. So, which means then, this exact difference, this is approximate difference. So I can as well write this one as error in x minus y is error in x minus error in y. But I have to give a disclaimer here. But note that maximum possible error is given by getting the absolute getting the maximum the absolute of magnitude of the errors. So this I mean that error in x minus y will be given by magnitude of error in this negative sign for this one, and then that should make sense. You know, when you're saying absolute value here, then I'm ignoring this negative sign that is on the error in y quantity. And before you ask a question, let's remind ourselves on, for example, if you remember in high school, Form 3, if I say find the error in, say, 42.5 minus, say, 40.1. So if this is my X number, this is my Y number. From high school, you know that error is given by a half into maximum value minus minimum value. So when you are doing the addition, maximum sum minus the minimum sum, multiplication, the same thing. So what is the error in the quantity 42.5? Correct, 0.05. You remember the thing we are saying that the least unit of measurement. So the least unit of measurement for 42.5 is 0.1. So error is a half of 0.1. So 0.05, correct. And then error in Y?
0.052.
0.05, correct. So you say if you fix if you say that now by definition that the error in the difference X minus Y, if you are to apply it blindly from what we have done here, without factoring in the aspect of the absolute of the magnitudes of errors, you are going to say that the error is 0, which is not the case. So error in 42.5 minus 40.5 is not going to be 0. So then now, which means then the number 42.5 is between 42.55 and
42.40.
42.45.
5.
And then the number 40.1 is between. So the maximum is 40.15.
15.
And then the minimum
40.05.
40.05.
40.05. So what would be the maximum difference. We take
42 point
maximum x minus
and minus minimum y.
minimum y, correct. Minimum y. So we are going to have 42.55 minus 40.05. So the answer is
2.5.
2.
2.5.
2.5, okay. Then now, how do we get the minimum difference?
Minimum x minus maximum y.
Minimum x minus maximum y, correct. So we are going to minimum x is going to be 42.45 minus maximum y is 40.15. So this will give us
2.3.
2.3.
2.3.
Okay. So which means then error by definition, error in this difference will be a half into maximum is 2.5 minus 2.3. What do you get?
0.1.
0.1. Yeah. So this will become the error in that difference. And you should see that is actually agrees with what we are saying here, that the error here is given by magnitude of error in x plus magnitude of error in y. So note that in the derivation, yes, this will come out, but then when you are defining the errors, know that these quantities must be positive. I'm very happy that a majority of you still remember what you did in high school Form 3. That's very abnormal. It has never happened. This must be a very crazy class. I have to be very careful on what I said, because people are revising seriously. That's good. So, so which means then now the formula for finding the error in difference turns out to be the same as the formula for finding error in sum, because it was the same as just addition of the two quantities. Then the second last thing, and then we close. This being the first day, it's bad manners to do all the 3 hours or the 2 hours. So let's discuss about multiplication and then division, and then we stop so that other things can be done next week. So multiplication. The game is the same. The song we sing in the first instance is the same song we are going to sing here. But then there's an interesting way to play with the equations to see how we find out the error in multiplication. So we start by saying that we know that if we take x, we subtract by x, we must always get error in x. And this means that absolute of x, the approximate value of x is the same as x minus error in x. We call it equation 1 in the usual way. And similarly, if you take y, you subtract by y, you must always get error in y. So which tells you that the approximate value of y is nothing but taking y minus error in y. So we call this one question 2. So then, because we are dealing with the multiplication, we are going to multiply equation 1 and equation 2. So multiply equation 1 and equation 2, we get by x multiplied by y is going to be x minus error in x into y minus error in y. I hope everyone is comfortable with that equation from 1 and 2.
Tuko pamoja.
The screen is not visible.
Oh, everyone is not able to see? Okay, let me unshare and then reshare. So are you able now to see?
Yes.
Good. So
Yes.
then now, multiplying equation 1 and equation 2 produces this equation. And let's see, let's do the usual opening of brackets and simplifying terms. So we are going to have bar x times bar y is equal to x by x is xy, x by y is xy, minus x times error in y, minus y error in x, then plus error in x, error in y. Then we say I will have x, y minus bar x minus bar y is the same as x, or I can say y error in x y error in x plus x error in y, then this should be minus, not plus. But it's just fine anyway. So we have x
positive.
Error in y plus y error in x, and then minus error in x, error in y. Hope that equation makes sense from the previous one.
Yes.
Yeah, good. Then we do what we call first order approximation. So to first order approximation, we neglect product of higher order terms of error terms and higher powers of the error terms. This statement of first order approximation will be very common in most of the derivations we are going to make in this course, and also as we grow up in the field of mathematics, it will be a very common statement to do approximation in some derivations. From the start, it is assumed that error in x and error in y are very, very, very small positive numbers. So this is usually the assumption from the start, that what you are calling the magnitude of errors in the quantities x and y are very, very, very small positive numbers. So when we multiply very, very small positive numbers by other very, very small positive numbers, then we even get a very, very small positive number. So that's why we are saying that we are going to ignore any term that involves the product of those error terms or even higher powers of error terms. So when power is 2, 3, 4, etc., we take them to be 0. So by that, it means that this part is assumed to be 0. So we do away with it. So which means then x, y minus by x by y. Actually, I can say less than or equals to, or I can just say equals to. Or I can say it's approximately equals to y error in x plus x error in y. So remember, when I write this and I put it's the same thing as saying approximately equals to. So we're saying that now, because we have assumed this thing to be 0, then the left-hand side is approximately equals to these two terms. And by definition, you see here is product of exact quantities, x and y. Here is a product of the approximate values. So following the trend of our definition of errors, which is the exact value minus the approximate value, then we can say the left-hand side represents nothing but error in x times y, which is y times error in x plus x times error in y. We can write equals to, or we can write approximately equals to. All of them will still be allowed. So this is the formula we use when we want to compute the error in product of two quantities. We can play with this equation and say, we know that relative error is given by error over true or actual value. This by definition. So relative error in the product of x and y will be written as error in the product x and y over the exact product xy. And then we can say, from what we have found in this equation here, where there's error in the product x and y, we can put y error in x plus x error in y. Then we divide everything by x, y. Now, if I give you I give you this fraction, a plus b over c, how else can we write it?
A over C plus B over C.
Correct. A over c plus b over c. So we do the same thing here. So there will be no mistake by saying this is the same as y error in x over xy plus x error in y over xy. We are not breaking any rule, neither are we making any or performing any miracle. The same equation. Then by doing that, some things will cancel out. So y and y cancels out, x and x cancels out. Okay. So this will give us error in x over x plus error in y over y. So we're saying that this is relative error in x times y. Then going back to the definition, what do we define the quantity error in x over x? What does it define?
Relative
What's the
error.
definition of this quantity?
Relative error in X.
Correct. Relative error in X. And this other quantity?
Relative error in Y.
Correct. Relative error in Y. So we are saying that the relative error in X times Y is nothing but relative error in X plus relative error in Y. So take this seriously. We may ask you to show that relative error in the product of two quantities X and Y is approximated as the sum of the relative errors of the two quantities. You may get some 2 or 3 marks there. So lastly, we are saying that we are saying that relative error in the product can be expressed as a sum of the relative errors. So the last operation, we call it division, and then we stop. So division.
Excuse me, sir.
Yes.
I don't know if I'm the only one who is not able to see the screen.
Let me unshare and then share. Are you able to see it from end now?
Yes.
Okay, good. So division, we use the same script. We know that. So at this point, when I say we know that by X is X minus error in X, by Y the same as X minus error in Y, Y minus error in Y, they make sense. I hope by writing this 2 equations, you see sense out of them. Okay.
Yes.
Good. So we are dividing. So divide equation 1 by equation 2, i.e. by X divided by Y is given by X minus error in X divided by Y minus error in Y. Remember, when you have equations, when you have 2 equations, you can always add them, you can multiply them, you can add them, you can subtract, you can divide them. All the 4 basic operations can be applied to the 2 equations. Then this, if I have a fraction A over B, how can we write it as a product of 2 values? If you are given A over B, how else can you write it as a product of 2 numbers?
A times 1 over B.
Correct.
1 over
A
B.
times 1 over B. Good. So we are going to apply the same thing to this right-hand side of our new equation. So we say that this is nothing but x minus error in x, then we multiply by 1 over y minus error in y. I hope by doing that, everyone sees that we are not performing any miracle. That equation is still exactly the same. And if I don't want to have 1 over b, I can write
B power negative 1.
if I don't want to write 1 over b.
B
inverse, correct. B raised power negative 1. Okay. So which means that by x over by y is nothing but x minus error in x times y minus error in y raised power negative 1. It is the same thing we had from the start here. Then when you are doing SMA 104, SMA 104 or SMA 103 or SMA 104, any of those, you must have done what we call the binomial theorem. States that if I have magnitude of h being less than 1, then 1 minus h power negative 1 is the same as 1 plus h squared plus h power 3 plus h power n. You know this from binomial theorem, eh?
Yes.
Yeah. So then now, you see, I can play with this. This thing here can be written as y into 1 minus error in y it will be the same bracket y minus error in y power minus 1. And then this using loss of indices is the same as y power minus 1, 1 minus error in y raised power minus 1. Okay?
Yes.
Yeah. So which means then this is nothing but we can write this as by x over by y is, remember, this is nothing but 1 minus error in y power minus 1 divided by y. Okay? So we'll have 1 over y into x minus error in x, then into 1 minus error in y power minus 1. So that should make sense. Then we apply binomial theorem to this term and say that this will be by x over by y is x over y minus error in x over y into 1 plus error in y plus error in y squared plus error in y cubed plus error in y power 4 plus other several terms, error in y power n, just by binomial theorem. That is what's generating that quantity. Then remember, we are doing approximation up to first order. So we can have first bracket, you multiply by 1 plus error in y, x over y minus error in x over y. Then we are sure that we'll have x over y minus error in x over y times error in y squared plus error in y power 3 plus error in y power n Do you agree with that expansion? Does it make sense?
May pardon.
Yes, it does.
See you on Tuesday, and remember to go through the rest.
Do you see how we are moving from this step to this step?
Yeah.
Those are going
Good. So then
Last
now,
step to the last step.
what we are sure is that all this part is going to be 0 to first order approximation. Remember, to first order approximation, you say that we assume that all the product of error terms and higher powers of the error terms with the higher powers means 2, 3, 4, etc. will be assumed to be 0. And so you see the smallest error term here is to power 2. So you are sure that this part will be 0 and all other things will be having powers more than 2. So the whole of this bracket will be 0. When you multiply by this other bracket, you get 0. So that's why I'm saying that everything here will be 0. Okay?
Okay.
Good. So therefore now we have bar y. So then now we open this ones here. So we have bar y, bar x over bar y equals to x over y minus error in x over y. So when I multiply this by this, I get x error in y over y plus I multiply this by this quantity here. I get error in x times error in y divided by y. And I hope you should see that also the last term on the right-hand side goes to 0.
Yeah.
Okay.
Yes.
Yeah. So we'll have so this also goes to 0 because we have product of error in x, error in y. So that now I'll have bar x over bar y equals to x over y minus error in x over y plus x error in y over y. And as usual, we put error terms together and we take exact and approximate on one side. So we'll have x over y minus by x over by y will be equals to
X over Y minus
okay. So
over
okay. So we have x over y, and then yes, 1 over x. So I'll have x error in x over y plus a minus now.
Minus.
I'll have a minus sign, okay?
Yeah.
Yeah, so I'll have minus x error in y over y. So this term with the error in x was there another y on the error in x? Let's just confirm that. In the expansion here, 1 over y. So x minus y, then y. Let's see. So x over y. 1 over y, that's correct. X over y minus error in x over y, correct? So this term with this term gives us so x over y times 1 x over y, and then x over y times error in y. So we have this term, and then that will be the two values, and then minus error in x over y, that's correct. And then minus error in y, that's fine. So then, which means the error in x over y is going to be error in x over y minus x error in y over y. So this will be the error value or quantity in the quotient of x and y. So just the so the expansion of the second part here. Seems we have missed an y squared somewhere. So from here, x minus error in x over y minus error in y. So we said x minus error in x, and then times 1 over y minus x. So this step is fine. Then error in by x over by y, so we'll have x minus error in x times y minus error in y minus raised power minus 1, so that's fine. Then this is the same as y into 1 minus error in y power negative 1. So all this is fine. 1 error in y over y. So then now 1 over y times this, so that's fine. So 1 over y times x is x over y. Then error in x over y, that's fine. Okay, so you are you seeing that there's a slight mistake in the bracket here? When you say for this thing to be the same as y minus, we need to put a y here. Are you seeing that? For that to be true, so that this quantity is equals to y minus error in y power minus 1.
Yes.
Yeah, we need to divide, we need to put here y so that when we expand, we get back the y minus error in y, okay?
Yes.
Yeah, so we need to have a y here so that if you are to open, you'll say y times 1 is y, and then y times minus error in y over y, you get now error in y. So we need to divide this by y here. So there's an error in y over y. So which means then there's a y here. So this is over y squared, y power 3, y power 4, divided by y power n. So because now you are h, if you relate this quantity here, 1 minus error in y over y, raised power negative 1. So the h in this binomial theorem will be taking the value error in y over y. Okay. So then now, where there's h in the binomial theorem, you put error in y over y. So that's why I'm dividing everywhere by. So this will be error in y over y raised power 2. So error in y squared over y squared. Error in y over y raised power 3. So every numerator and denominator raises to the same power. Then error in y over y raised power 4 will be error in y power 4, y power 4. Similarly, error in y over y raised power n, you get error in y power n over y power n. So here we also have y squared, we have y power 3, we have y power n. So which means then here we have this over y, okay? We are saying that is y because you see we are picking these first two terms are the ones that will have at least those are the only two parts in all this second bracket that will give us quantities which have either one error value or a quantity that doesn't have an error value. But from this third term up to the end of the series, everything will be 0 because the powers of the error terms will be 2 and more. So then I take this bracket, I multiply by 1. So this is what I have here. So there's a 1 here. And then I take this same bracket, I multiply by this quantity here, error in y over y. So that's why I have this over y here. And then the same bracket times all these higher order terms. So which means then I'll have error in y over y times x over y. I'll get x error in y. So this will be a square here. And then error in y over y times minus error in x over y. I'll also have a square here. But this would still go to 0 because we have product of x, error in x and error in y. So which means then I'll have a square here, this term, and then there's a square here for this term. And so I have a square here. That is what will be the value of that error quantity. And which now you can say, if you are to put under the same LCM, we'll have y squared, then y times error in x minus x error in y will be the error in x over y. So that if you are to define the relative error in x over y will be error in x over y divided by x over y, which will be y error in x minus x error in y divided by y squared divided by x over y. And so this will be y error in x minus x error in y over y squared. Then you multiply by the reciprocal, which will be y over x. Then this y cancels one y here, and we'll get y error in x minus x error in y. Then y times x is xy, which you can split as y error in x divided by xy minus x error in y over xy. So what will be the value of the first fraction? When you simplify the first fraction, you get?
Error of x over x.
Error in x over
Correct,
x.
error in x over x. And then this and this cancels out. So you have error in x over x minus error in y over y.
Over.
Yeah. So we can also say that relative error in the quotient of x and y is the same as relative error in x minus relative error in y. So as you saw that the relative error in the product of two quantities can be expressed as a sum of the relative errors. Similarly, the relative error in the division of two quantities can be expressed as the difference between the relative errors. So exercises are not assignments. So we don't mark them. It is part of your notes. You continue writing them in your book. So one, discuss different types of errors. Number 2, derive and provide at least 2 examples on error propagation for a function of more than one variable. So those are the only two assignments, 2 exercises I want you to work on. I'll share the relevant material to help you do that. And then also the link I shared, it also has enough previous lecture videos to guide you on what you're supposed to do. If need be, then I can as well share the link to this recording for your own reference. So I wish to stop at that point, and I'm sorry that I'm stealing from you because I'm stopping before the actual time for me to stop. But it's my culture that day one, it is bad manners for me to teach all the hours. Please allow me to steal from you only for today.
Okay.
Please
Are you
share
giving me
that
permission to steal from you?
Still
Am I
for us
permitted?
every day, man. You are permitted.
Hello? Okay, good. Thank you. So I'll share the recordings if necessary, and then also the reference material to help you follow through. As someone had requested earlier on, is it necessary for me to also to share what I was writing here? Should I
Yes, if
scan and
possible.
share through the class rep?
Yes.
Yes, you can share. Yes.
Okay, good.
Yes.
I'll do that.
Please
So
share
if I
the
forget,
notes.
please class rep. Then the class rep for the Kenya Science also, please let me also have your contacts. My contacts are in the document I shared through the class rep for Kikuyu campus. Then you can use them also to access me so that we can have a direct communication with you. Have a good day.
So is this for
Thank
major,
you.
major or is for everybody doing maths?
Come again?
I'll text you.
Okay.